Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so we are in part 3, lecture 4. Lecture 3, from part 4 of the topic 5, function and graphs, with 5.3, inverse function. Okay, so before I continue, that I do hope that all of you may support my channel by click to subscribe, click the link share, and like button and bell notification, so that you will get more information about my next channel, my next video in future. Okay, so today, okay, I do hope that all of you have your lecture notes in your hand right now, so that then at the end of lesson, students are able to show whether a function, the function that we discussed in next, has an inverse, and find the inverse of the function. So before that, we hope that students are able, at the end of the lesson, students are able to compute the inverse of the function, identify the domain and range of an inverse, and we may sketch the graph of function f and its inverse on the same axis. Okay, so a function is 1 to 1. Okay, the condition to see whether the function has an inverse or not, it is the function must be in a condition of 1 to 1 function only. Okay, so to see whether the function of f is 1 to 1 function, if this one here, fx1 equal to fx2, implies that x1 equal to x2. Okay, so an inverse of f exists only if the function of f is 1 to 1 and onto function. Okay, so the first one here, okay, let's begin with, let's say, make this one as an fx1 equal to fx2. Okay, so 3x1 plus 2 equal to 3x2 plus 2. So minus 2 left and right. Okay, here, and it gives us 3x1 equal to 3x2. Okay, and multiply 1 over 3 or divide by 3 left and right. Then it gives you x1 equal to x2. Okay, so we write down, recall the conclusion of this. Thus, fx1 equal to fx2. Okay, so then fx is 1 to 1 function, and fx has an inverse. Okay, so we write down the conclusion then. Next one, same, we call as we treat the first example, the previous example, then we come up with fx1 equal to fx2. It is x1 squared plus 4x1 plus 1 equal to x2 squared plus 4x2 plus 1. Okay, so then minus 1 left and right. Then x1 squared plus 4x1 equal to x2 squared plus 4x2. Okay, so bring all this to the left side. x1 squared minus x2 squared plus 4x1 minus 4x2 equal to 0. So for these two, okay, we may factorize as a x1 minus x2 and x1 plus x2, okay, plus with factorize 4, then x1 minus x2 equal to 0. Okay, so then now we may factorize, we simplify this as an x1 minus x2, and then okay, simplifying this, I recall short from the the notes. It is x1 plus x2 plus 4 equal to 0. So there are two factors here right now, which is x1 minus x2 equal to 0. x1 plus x2 plus 4 equal to 0. Then x1 equal to x2, x1 equal to negative x2 minus 4. Okay, so there are two possibilities values of x. Okay, so there's, okay, since there are two values of x1, okay, so there are two values of x1, so then fx is not a one-to-one function, and fx has no inverse. There you go. Okay. Now, graphical approach. If a straight line that is parallel to the x-axis is drawn and is at most cuts the graph at only one point, then the function is one-to-one. The graph that parallel to x-axis, as we know that, we call y-axis and x-axis. So if there's a graph, okay, if there's a graph and then we make a line that parallel to x-axis, okay, let's say y equal to an a. So we can see here it cuts at more than one point. 1, 2, 3. So let's take a look back at the definition here. If the straight line is parallel to the x-axis drawn and it at most cuts the graph at only one point. So how many points that we cut here now? It cuts at 1 point, 2, and 3. Then the function is 1. Okay, this function, this graph is not a one-to-one function. Okay, so that's example then. So then graphical approach. For graphical approach of this function fx equal to square root of x minus 2. Okay, as we know that the function inside, okay, the function inside is only valid where x minus 2 can only be greater than or equal to 0 with this one here. So then it is x greater than or equal to 2. Okay, now okay, so x greater than or equal to 2, it begins with 2 here, and the shape of this graph is something like this. Okay, so now let's recall a line that parallel to the x-axis, something like this. Okay, the line of y equal to 1 parallel to x-axis. Okay, it cuts only 1 point here. Let's make another one here. It cuts at 1 point. Another straight line. It cuts at 1 point. So what's our conclusion then? A line drawn, okay, a line drawn parallel to the x-axis only cut the graph of fx, okay, equal to square root of x minus 2 at most 1 point. Okay, I copy it all back. We call the conclusion in the sentences here. Okay, 1 point. Thus fx, okay, thus fx is one-to-one function. Okay, and fx has an inverse. Okay, then example of this. Okay, to sketch the graph of modulus of x plus 3. Okay guys, I begin to explain to all of you. I begin with a function of fx equal to x plus 3. Okay, ignore or leave it this for a while. Okay, ignore this sign of absolute values. Just focus on this one here, x plus 3. Okay, so to sketch a linear graph, we need only 2 points, 2 coordinates. Okay, let's begin with, let's say, if choose any values of x, or one values of x and one y. Okay, I begin, okay, start with when x equal to 0 and when y equal to 0. So that when x equal to 0, okay, f0 equal to 0 plus 3, then y equal to 3. Okay, and when y equal to 0, just imagine the whole function here, x plus 3 equal to 0, then x equal to negative 3, x equal to negative 3. So the coordinate of 0, 3, 0, 3 above here, okay, and negative 3, 0 here. Okay, so make a line here. Sorry. Okay. Okay, just imagine that this is a graph of x plus 3. Sorry then. Okay, this is a graph of x plus 3. Okay, now this is the graph of y equal to x plus 3. So when it comes to the sign of absolute values, okay, when it comes to the sign of absolute values, meaning any graph that lies below the x-axis, below the x-axis, below the x-axis. Can you see when a graph that below the x-axis? Yes, here. Okay, this graph will, we call reflex or shift, reflex above the x-axis. Okay, okay, for this one, in this case, it reflects with the x-axis here. So then it come up with this one. Okay, earlier we discussed about the function of fx equal to x plus 3. Then we got this straight line. Then back to the original question that we are looking for the function of fx equal to absolute values of x plus 3, meaning any graph that below the x-axis will reflect above. Okay, reflect or shift above here. Okay, so then we are going to sketch the graph of the question only. So what are we going to do next is, okay, so now we just now we sketch the graph of x plus 3. Then we add up with the sign of absolute values here. Then we reflect or bring the, we call the graph that below the x-axis above. So this is it now. Okay, this is it. This is the graph of absolute values or modulus of x plus 3. Okay, now make a line that parallel to x-axis. Okay, let's say y equal to 1. And you can see here clearly here that it cuts at 2 points of the function of the graph. So a line, okay, a line drawn parallel to the x-axis, okay, cut the graph at 2 points. Okay, thus fx is not a one-to-one function and has no inverse. There you go. So the inverse of the function, if fx equal to y is one-to-one function, therefore the inverse is denoted by f inverse exists with, okay, this one here. So using the property, if f gx, the composite function of f between g and f, or f with a g, it gives you the result of x. Okay, implies that f is inverse of g, or g is the inverse of f. Okay, so just imagine that is f here, so this is considered as a gx. Okay, and domain of the function f is a range of f inverse, example, okay, and range of f is also equal to domain of f inverse. Okay, so in recall, to make it simple, if we have the function of fx and f inverse, so we have a domain of f and range of f, domain of f inverse and range of f inverse. So we come up with conclusion that the domain of f is also range of f inverse, and the range of f is a domain of f inverse. Okay, so example 1. Okay, so example 1, what's the question then? Okay, we are going to find the inverse of this function. Okay, there are two methods of find the inverse that I'll share with all of you here. The first one here, f composite of f and f inverse of x equal to nx, based on the definition just now. Okay, so then recall composite between f inverse and f into an f, meaning we substitute the f inverse into an x of the function f. So then substitute f inverse here, you come up with 2 f inverse of x plus 1 equal to an x. Okay, so then bring this to the other side, it becomes minus 1, and then f inverse of x equal to, okay, 2 multiplied with f inverse, so then we come out with 1 over 2 x minus 1, or 1 over 2x minus 1 over 2. Okay. The other method here is, if I change this term of fx into y equal to 2x plus 1. Then just imagine that if I bring this negative, this 1 to the right side here, okay, 2x equal to y minus 1. Okay, and then x equal to, okay, divide by 2 left and right, it gives you 1 over 2 y minus 1. So we come up with a conclusion that f inverse of x equal to 1 over 2 times x minus 1. Yet still the same actually. Okay, Okay, there you go. Now, the graph of F inverse, okay. Okay. So we rewrite the function of fx equal to 2x plus 1 and the function inverse of x, F inverse, what we get just now is 1 over 2 times x minus 1. Okay, so we are going to sketch both graphs on the same axis. Okay, so class, to sketch the graph of f and its inverse on the same axis, there are one thing that you can use as a guidance, okay? Or the one things that we need to remember, that inverse, the f and its inverse reflects, okay, reflects from the we call the line of y equal to an x. So in this case, f y equal to an x, I just imagine that it is a mirror, okay. Okay, y equal to an x. So y equal to an x form 45 degree from this line to the x-axis, and also 45 to between this line and y-axis. Okay, now let's sketch the graph of fx, function of fx, 2x plus 1. Okay, for this one here, when x equal to 0 and when y equal to 0. When x equal to 0, y equal to 1. And when y equal to 0, 2x plus 1 equal to 0, bring this here, negative 1, then x equal to negative 1 over 2. Okay, so then, coordinate of 0 and 1. 0, x 0, y equal to 1 here. Okay, x 0, y equal to 1. And then x negative half, y equal to 0. Negative half, somewhere around here. Okay, negative 1 over 2. So just imagine that if we, okay, I sketch this with a free hand, so it's not as smooth as you sketch on paper with when you have the ruler with you. Okay, so this is the line of fx equal to 2x plus 1. Okay, so just imagine that if I reflects this coordinate of negative half for this function of f inverse. Okay, so negative half, so you imagine that also negative half here, negative half, and 1 reflects here with 1. Okay, so sketch this. Okay, I'm sorry, wait. Okay, I meet again. Okay, it will, okay, something like that. Okay, class, I might sketch this not very nice. Okay, so I use these apps helping me to sketch the graph. Okay, for example, Okay, you can see here now. Okay, okay, so then you can see clearly the first is y equal to 2x minus 2x plus 1. And the next function is 1 over 2 in bracket x minus 1 as an inverse. Okay, so this is the proper graph. Okay, sorry. Okay, so I showed it again. The graph of both of the function y equal to x plus 2x plus 1 and 1 over 2 times x minus 1. Okay, class, for sketching a graph, you may use the apps or surf into the website of www.desmos.com. Okay, so this we call website will help you to sketch the graph, and you can see it clearly how to sketch the graph, and we call to understood the process. We call the pattern of the graph then. Okay, so this is it. The first one then. The graph of f inverse is the reflection of the graph of f on the line of y equal to an x. As I mentioned just now, y equal to an x is as a reflection mirror to the graph of f. Okay, example 2. Given this one here, find f inverse, sketch the graph on the same axis and determine the domain and range of the function f and f inverse. Okay, so what's the question just now? Square root of x plus 2. Fx equal to square root of x plus 2. Okay, so then find f inverse. I'm what we call comfortable using this method of let's fx equal to y equal to square root of x plus 2. Okay, so then square left and right. Then you come up with y squared equal to, cancel between these two, then you get x plus 2. Then x equal to, bring these 2 to the side, become negative, then come up with y squared minus 2. So f inverse of x equal to x squared minus 2. Or you may also, let's say, use we call the method that we propose in this lecture notes. Okay, never mind. F with f inverse of x equal to an x. So substitute f inverse into an x of the function f. So it is now square root of f inverse. Okay. Substitute x with f inverse plus 2 equal to an x. Okay. So we squared left and right, cancel between these two, so we come up with f inverse of x plus 2 equal to x squared. So bring this to the side, x squared. So then f inverse of x equal to x squared minus 2, yet it's still the same. Okay, this is option number 1 and this is an option number 2. You choose either one. Okay, now sketch the graph of f and f inverse on the same axis. Okay, so now okay, and don't forget that we have another line that separate between the f and its inverse, which is the line of y equal to an x. Okay, there you go. So now let's sketch the first one here, square root of x plus 2. Okay, this one with a graph starting with 2 here, starting with 2 or negative 2. Let's say, okay, this the whole function is exists if x plus 2, okay, if x plus 2 greater than or equal to 0, then x greater than or equal to negative 2. Okay, so it means that it begins here. So negative 2, and the graph will be something like this. Sorry. Okay. Okay, graph will be something like this. So now class, because line of y equal to an x as a reflective mirror between the graph of f and its inverse. So if this is if this is the graph of f, so what will be we call the coordinate of graph for f inverse? Okay, bring this negative 2 here. Okay, and this shape reflects on the other side. There you go, something like that. Okay. So this is an fx and this is f inverse. There you go. Okay, now what is the domain of the function f and the range of f? So look at this one here now. The domain we use this automatically. This is the domain of the function. So it is now negative 2 to positive infinity. According to the graph here, the value of x from negative 2 to positive infinity. Okay, and the range of f, the range is all about value of y. Value of y starting from 0 and to infinity, because the graph of fx may we call at least numbers here with 0 here, then the graph is all above the x-axis, so from 0 to positive infinity. So what is the domain of f inverse and the range of f inverse? Please read the definition just now. The domain of f is a range of f inverse, and the range of f is a domain of f inverse. Am I right? Okay, so just rewrite everything here. The domain of f is a range of f inverse, so then it is negative 2 to positive infinity. And the range of f is a domain of f inverse, so that the domain of f inverse is 0 to positive infinity. There you go. Okay, the domain of f inverse. This is the graph of f inverse, and the domain here is, look at the value of x starting from 0 to positive infinity, and the range from negative 2 to positive infinity. There you go. Okay, now, okay, example 3, find f inverse, sketch the graph f and f inverse on the same axis, and determine the domain and range for both of f and f inverse. Okay, using the properties. Okay, using the properties first, which I think that we find the inverse using the algebraic method first. Okay, x squared plus 2 fx equal to x squared plus 2. Okay, so here let's say if I use the algebraic method here, algebraic approach. Let fx equal to y. Okay, substitute or replace this with y. So y equal to x squared plus 2. Okay, and then bring these two to the other side, become negative. So then x squared equal to y minus 2. Okay, x squared here, and then 2 bring it become negative, so y minus 2, and x equal to square root of y minus 2. Okay, so x equal to plus minus square root of y plus 2. So then, okay, according to the question, since that x greater than or equal to 0, so then we choose the value of x, which is x equal to plus square root of y minus 2, or for this one here, f inverse of y equal to square root of y minus 2, and change the y into an x, which is f inverse of x equal to square root of x minus 2. Okay, let's say using the we call algebraic approach. Okay, using the properties, f inverse of x equal to an x. Okay, in composite function, we substitute f inverse into an x of the function f. So then substitute f inverse here, f inverse of x, okay, x squared plus 2, so f inverse square plus 2 equal to x. Okay, then f inverse of x square, 2 bring to the side become x minus 2, and then f inverse of x equal to square root of x minus 2. Okay, for we call square root left and right, they come out with positive and negative. So since that x greater than or equal to 0, so f inverse of x equal to positive square root of x minus 2. Yet still the same. Okay, now b, okay, the graph of f and its inverse. Fx, okay, the function of fx we get just now, which is x squared plus 2, and f inverse of x equal to square root of, sorry for this one here, f inverse of x equal to square root of x minus 2. Okay, so okay, y equal to an x, okay, now for this one here where x greater than or equal to 0, according to the question, yes, x squared plus 2, x squared, x greater than equal to 0. The graph of x squared plus 2, okay, fx equal to x squared plus 2, just imagine that if I make this one as an x minus 0 square plus 2. So when x equal to 0, y equal to 2, actually that this is the minimum point, and at the same time is a where it is symmetrical for the graph of x squared plus 2, meaning that it will be something like this. Okay, maybe something like this. Okay, I sketch the graph here. Okay, okay, this is x equal to 2, y equal to 2, Anyway, this function is valid for x greater than or equal to 0 only. X greater than or equal to 0, starting from 0 here and the value of x to the right. So it means that it's only valid for the graph on the right side of this. Okay, then clear this. There you go. So this is a graph of, according to the question here, fx equal to x squared plus 2x greater than or equal to 0. This is the one. Okay, this is the function of fx. So how's the graph? What about the graph of f inverse? Okay, as I mentioned to you just now earlier, that this line of y equal to an x is just like a reflective mirror. Reflects from here the function of f and its inverse here. It's just like an object with its image. Okay, so the f and the image, which is f inverse, come up with here 2. So 2 and 2, and then there you go, f inverse. Okay, again, you may use the apps of desmos.com or any other mathematical graph apps to help you to see, to recall the difference between the f and its inverse, and what is the function of line of y equal to an x for both of f and its inverse. Okay, now what is the domain of f and the range of f? The domain of f inverse and the range of f inverse. Okay, so according to the graph of fx, the domain is, okay, refer to the x here, refer to the x, okay, refer to the x-axis, where the value of x from 0 to positive infinity, or you may just straightly look at this one here. The domain is x to positive infinity. And the range, okay, look at the graph here, the least value of y is 2. And the rest, we call the graph point to the y, all positive value to infinity. The graph, okay, the graph list only until 2 here with a minimum of 2. So then we come up with 2 to positive infinity. Okay, and domain of f is a range of f inverse. And range of f is a domain of f inverse. There you go. Okay, example 4. Okay, for example 4, okay, what if I just let all of you try by yourself? Okay, try by yourself. Use any mathematical apps from the website or from your smartphone. Okay, and test yourself and see whether you understood. Recall from my previous explanation of example 1, 2, and 3. So hopefully that you can recall, sketch, and solve this question of example 4. Okay, so I leave it to all of you. If you can't, then bring this method into the class. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.